is a PhD from University of Oklahoma and is currently working. We're getting there. Got it. Is currently working with diversified well logging, but remains an affiliate with OGS. He saved the day with a lot of projects at OGS, and we're very, very grateful and looking forward to working with him in the future. And he'll share some of his findings this morning. Basically, for those who don't know, the OGS is a unit in the Mewburn College at the University of Oklahoma, but it also sits in the state agency family, now overseen by Secretary McQueen, an appointed secretary in the state apparatus. And that includes many of our guests here from the Oklahoma Water Resources Board, from the Oklahoma Water Resources Board, from the Oklahoma Corporation Commission, and other agencies. So I'll go over the outline in a second. I want to really welcome Tali Redford from the Osage Mineral Council. Thanks for making the trip, Tali. It's really wonderful to have you here. The Osage people have been really welcoming to me in my 2 years in Oklahoma so far, and we've had a lot of great discussions about how to work together. I want to welcome Mike Smith from the Advanced Hydrocarbon Stratigraphy Group. They've been a really great supporter of these workshops and continue to do so. That's the AHS logo in the center there. And Mike is here with us, which we're really grateful for. And give a wave, Mike. Just hold your hand. There he is with a green shirt, strapping young lad over there. John Antonio is the incoming dean of the Mewburn College for Earth and Energy. He's going to be directing the school that houses Geosciences, Petroleum Engineering, OGS, and the Urani Center, which does certificate programs. So John's there if you have questions for him or want to hear his ideas. We're really grateful he could attend today. If you registered and paid, your funds go towards today's event, but they also go into our workshop account. And this is really what makes so many things possible for us. And we're welcoming our industry sponsors, including Premier Horrocks. Basically, I'm going to jump ahead a little bit and we'll, let's see. I'm going to jump around, sorry. We'll make sense of this in a second. This is an example of the kinds of things we do. We have publications on our website. They're PDFs that have been peer reviewed. You can download them for free. I'll get there in a minute. You can download these for free. They're basically historic. We do have to pay to create them and put the content online. So the workshop account helps this kind of activity. We have two new volumes from Brian Cardat, Bolton 152. Many of you have been using this for over a year. Gets high praise, and of course Ken Johnson Circular. We're going to start an OGS award that is going to honor Ken Johnson, who's here with us today. We're so grateful for you being here, Ken. We're going to start a Ken Johnson Award. Where this goes, we hope will become bigger and better. We're going to start modest with an award to our staff to recognize their service to geology, and that will be the Ken Johnson Award. Today, the Charlie Lincoln Award is a national award given once a year to members of the state surveys. So we're hoping that over time, the Ken Johnson Award will be right up there, because Ken has, if you don't know, has spent an illustrious career with the OGS, going back to the good old days of hitchhiking around the country and all the amazing stories. If you haven't heard them, I encourage you to grab Ken and have a chat. He's here today. But he's a global expert on salt and stratigraphy and has written a lot about Oklahoma's salt and stratigraphic systems. So with those announcements, I mean, I think you get the picture that we are this state agency. This is our favorite photo of 1908 of Charles Gould. Actually, this was taken in 1909. He's the fellow in the tie. He has a nicer beard than I can possibly grow. And if you haven't read his memoirs, Covered Wagon Geologist, I'd highly recommend it. He started the survey and then started the geoscience program at OU. And so we go all the way back. And today we are a staff of between 22 and 28 people, depending on the month. But we're hiring today staff scientists, and we're growing as our projects come in largely on the things I'll talk about in a minute. And you can see that we're about half PhDs who can write papers, proposals, and then the people who really make it all go. we've become a pretty flat organization. We don't have a lot of silos and hierarchy. So if you write an email to me and say, Nick, what's going on with this geological problem? Chances are I'll send it out and you'll hear back from somebody here. So we've really worked hard to create a collegial and respectful environment that's really working at a high level. I really think that at its best, the survey is a connective tissue between the state, the university, the energy industry, the region's higher education, OSU, Tulsa, the HBCUs, federal agencies, the townships, tribal nations, all of these people. When it comes to geology and energy, at our best, we're bringing them all together like we are today. So again, thank you for coming. Molly has been running a geologist office hours that all the staff have been participating in. Once a month, people come from all over the state. They bring their meteorites, which tend not to be meteorites, but we've had interesting coins, we've had great fossils, and we sit around and identify them, and we can even use some analytical facilities when we need to. This has really exploded. We hear from all corners of the state of people excited to come visit us, and they've really enjoyed it. And somebody made the comment to me the other day that for every person we see, there's probably dozens more who've heard about it, but just can't make it and will eventually. So I think it's an outsized impact there. Many of you know that one of our core facilities is the core facility, the Oklahoma Petroleum Information Center, a turn of phrase by Charlie Lincoln, OPIC. Basically, it's about 3 football fields of core from the state, the last repository for the industry's coring, that the permitted coring, when they're done, come to us. You can access that core, you can access the logging data, both in paper records and soon digital records. And many of you have taken advantage of these facilities. We are unrolling today, actually. Richie Tarver, the OPIC manager, could not be here today because he's in Austin at an AAPG meeting giving a special presentation about our new well viewer. This is in its beta form, but soon you will be able to, through our website, open this up, click pull down menus on the left of all of Oklahoma's wells and geologic maps and scans of our core, and be able to really work digitally through our data sets. And this is free, just like our publications. You just go online. It was supported by SOAR, a sort of tax fund that industry supports, that we were able to get a grant from and develop this. So I encourage you to use it, and we'll find out if once it's live, if everybody logs in at the same time, we'll see if it doesn't crash, and, and then you'll be able to explore it. It doesn't have analytical facilities, but obviously we can build on it over time. So I'm going to turn this over to Carl next, basically, and he's going to give us a walkthrough of some analyses he's done of where we come from with the hydrocarbon industry, where we're going, how produced water from that industry fits into this, and then we'll kind of talk a little bit about the energy transition, and then a little bit about Oklahoma's critical minerals to kind of set the stage of why we made this meeting a kind of interdisciplinary meeting about our energy needs. Okay, take it away, Carl.
Hello, everyone. So as all of us know, Oklahoma is blessed with abundance of hydrocarbon resources in several important basins and up on the Cherokee Shelf that date all the way back to the earliest days of the oil and gas sector. This is an excellent map that demonstrates that, showing a lot of the hydrocarbon pools producing gas and condensates and NGLs and how they fit into the geologic context. But in the last few years, seems like we're coming out of the last downturn. We're preparing for the next boom in the cyclical industry. And it is important, I think, that part of the energy transition picture is not an abandonment of oil and gas. It's a supplement, especially in an energy intensive state. And so we want to have a nod to that and some of the how the industry has matured since the onset of unconventional resources, which has especially been really good for the state of Oklahoma. And so if you just look over lateral length production over the last 15 years, you can see that on average, lateral lengths have increased from a half mile to, you know, a good, depending on the section size, but we're almost, the majority of wells that are being produced are going to be in 2-section laterals. And our completions designs have actually improved a lot too. You can see that between 2011, we've gone from an average of 933 feet. So on this bottom axis, you can see that that's all right. I'll turn on the little laser pointer here. There we go. You can see the years here on the bottom, and then this is the lateral length. And then this is water intensity, how many gallons per feet that we pump into these systems and how much proppant per feet. You can see how our drilling completion practices have really matured. Additionally, it's kind of interesting to look back over the last 20 years and see these plays evolve naturally and how the thought processes have gone into it. So in 2002 to 2004, there was 248 horizontal wells drilled primarily in the Oklahoma Basin. Natural gas was still the major commodity at the time. And then around 2006, there was a discovery that you could make Oklahoma Woodford gas, and it's starting to begin to pick up. And you can see that there's 760 wells being drilled primarily in the Oklahoma Basin. And you can see that that play began to blossom and flourish. And then we have our first few exploration wells and that Devon produced in the Western Canadian County, which would later become the Cana play. I heard from Walter Lamley that it was called that because their map was offset. And so looking at the map, the big county line that said Canadian County, so they called it the Cana play. And so you can see that deep Woodford gas grow. And then the discovery of the Mississippian plays in the north part on the Cherokee platform from the Frank saltwater disposal well. So it was called the Miss Frank play. And that was starting to be produced upon the Cherokee platform after the gas price commodity crash in 2009, looking for more oil and gas. And so as that play begins to develop, you can see water production begins to outstrip our oil and gas production, which is also rising. And so by 2014, the Miss play and is in full bloom, and we have produced more water in 2014 and 2015 than we have since then. And that comes with some externalities that many of us might have felt, some earthquakes that came out of that. And so then the Stack Scoop play is being discovered. And by 2016, 2018, it starts to level up. And then the Anadarko Basin really begins to flourish. And our water production and the need for that saltwater disposal and reuse is beginning to go down. And so this is a look back on the oil and gas production in the state over the last 20 years, how unconventional resources have blossomed into several plays, which have been really successful and really important for the state of Oklahoma. We had an opportunity to learn a lot about the effects of produced water and the correlations that we saw between the need for environmental responsible stewardship of the resource and water production and the intensity and frequency of earthquakes in the state. And so I think I'm going to hand it back to Nick.
Great. Thank you, Carl, for walking us through where we've come from and also where we're going. Obviously, the continuation of oil and gas production will continue, as we'll talk about in a minute. I'll just backtrack briefly. For those who don't know, we run a public network of seismometers that Jake Walter here will talk about later in the context of the meeting. And that is one of our other brick and mortar facilities that we offer the state, the university, and universities. And the data are used globally by seismologists to understand this kind of rate of seismicity and its connection to activity. And here you see a snapshot that I took a screen grab yesterday from the web portal, which again is freely available online. This is literally yesterday's screen grab of our network in triangles and then earthquakes in circles that Jake will talk about. And I think to set the stage for the produced water discussion, what you see on the screen here is from 2010 to 2020, a compilation of earthquakes at greater than 3, so that's greater than magnitude 3, that should have an M, greater than magnitude 3 per month. In black, that's this black curve. And then the Arbuckle injections, that's injection into the deep carbonate formation in millions of barrels per month. obviously approaching 90 here, approaching 100 earthquakes here. You see it's not a one-to-one correlation over that decade, but there is clearly some kind of ramp up in earthquake activity. And so how we manage that with the network and the Corporation Commission and industry is something Jake will explore a bit more in the context of where we're going. So let's talk a little bit about why we named this about the energy transition, state of the state, the workshop. And I think we want to step back, and I know this is a charged topic and there's many diverse opinions about this, but I'm just going to walk us through what has driven the kinds of investments the federal government has been making over the last 2 years. And in fact, it's a continuation of the kinds of energy plan at the federal level that started under Vice President Cheney in 2004 and have continued till today. If you go and look in the way it's structured, it's been pretty consistent. It's just now we're seeing levels of investment that make everybody sit up and take notice. So what this plot is showing is 3 graphs in time from 2020 to 2050. This is from a Princeton University study. And this is, each of these goes from 2020 to 2050. And as I don't know whether it was Groucho Marx or Yogi Berra said, the problem with predictions is you have to tell the future, but we are basically looking at, these are oil and gas derivatives, natural gas, coal, diesel, gasoline, jet fuel, et cetera, distillates. So the reference model, this is if we decide not to do anything as a society, we basically don't change our level of hydrocarbon use, and supply and demand would have some kind of background flux. If you want to have a net zero economy, one that does not produce CO2 into the atmosphere, and the argument here is that obviously this isn't even removing CO2, it's just arguing if we're going to be able to manage carbon in the atmosphere, net zero would be the goal. Well, on the right is your most extreme model. And there's about 9 of these models, I'm showing 3. So this model here, well, is basically saying we're not going to use oil and gas in 2050, I think, or hydrocarbons at all. And so most of us, I think, in this room would probably argue that is not going to happen. And most don't think it will. So if you want to have a net zero economy, models like these wedge models suggest we need to grow a pretty appreciable carbon capture and storage component to this wedge. And this is setting aside what's possible, how much CO2 gets sequestered. It's just basically a wedge model saying if you're going to continue to emit CO2 and you want net zero, you have to put it somewhere. So the way carbon capture and storage is looking, this is a somewhat out of date paper, but it is one of the last kind of, one of the most recent peer-reviewed papers that goes over essentially what the CO2 picture looks like. And what you see are green dots are things like ethanol production, natural gas processing, hydrogen, industrial hydrogen production along the coast. These are the fixed large industrial CO2 emitters, not the vehicle fleet on the roads. This is the actual agricultural processing and its CO2 impact. And what you see is that those have been coupled with CO2 pipelines and these kinds of yellowish beige pictured spiders that kind of grow around the country. It's actually, this map is missing some, as many of you know. For several decades, there's been a series of pipelines here to the EOR fields of northern Oklahoma. This is kind of the industrial model for carbon capture in the mid-continent. Now, along the coast, the Gulf of Mexico, are things like this, these kinds of really high storage capacity areas, the Miocene formations of the proximal Gulf, things like that. But what you notice is the distribution of CO2 production is very scattered geographically. So what is starting to happen, and we're seeing it from, for example, Continental Resources and Summit Carbon Solutions approach, which OGS is not involved in. I want to disclaimer, I'm just holding it up as an example, is the development of a pipeline planned that would go to North Dakota, which has primacy. It is able to regulate its own carbon injection, CO2 injection, and that would be the site of injection. So North Dakota would benefit from the tax credits available for injecting CO2 from the industrial build out of this kind of system. And then the partners here would benefit from sequestering the CO2 they're producing. And that's kind of the picture we're looking at going into the near future is how is Oklahoma going to fit in this mid-continent economy of carbon capture. I'm going to turn it back to Carl to talk about geology.
So on your left to the side, in celebration of this sort of topic, which includes a lot of geostorage, just a friendly reminder that in this bay, that in Oklahoma, we do actually have a lot of phenomenal reservoir rocks as evidence of generations of conventional production. And for the last 20 years, especially when I was cutting my teeth in oil and gas, everything was about shale and nano Darcy perm. And so we thought it would be a breath of fresh air to remind the geologists in the room of some of the phenomenal sandstones and geostorage opportunities that exist in the state. So here we have pictures of the Virgilian aged granite wash and from Beckham County. We have some Red Fork from the early Pennsylvanian, Red Fork Dornian, and then we have the Arbuckle Formation. There's surprisingly little core of the Arbuckle Formation, even though we use it as an abundant saltwater disposal. You can see some excellent bugs. And then lastly, I want to talk a little bit about the gabbro that we're also showing in the southern Oklahoma igneous province, because it has a very interesting story, and we think a pretty nuanced, a lot of potential moving forward. So we'll talk about the origin of the southern Oklahoma igneous province and some of the basalts we have there as a discussion of how cookies break. And so if you've ever held up a chocolate chip cookie and you push your finger into it, it doesn't break in two, it always breaks into threes, which is an oversimplified geologic explanation for why we get triple junction systems and why Oklahoma has a large igneous province. When the Atlantic Ocean was opening during the Precambrian and early Cambrian, it tried to open here in Texas and along the southern states. And so that triple junction opens up in the southern Oklahoma here, which would later become the Wichita Mountains. And you can see it shows up in a gravity anomaly as a large subsurface igneous province. And so when the system was opening up, isostasy pulled, the crustal thinning pulled up mantle, which would then go through decompression melting and create what was first deposited was a large mafic province of gabbros and basaltic flows. And then later, the Carlton rhyolites flew over the top of it, creating kilometers of Carlton rhyolite. And then later, the Wichita granite plumes came and filled the gaps between those systems. These would later become weak spots that would rise up to become the Wichita Mountains. But we have a very large subsurface igneous province, which includes an abundance of mafic rocks, and the full extent of those systems are not well understood. Why that's interesting is because basaltic and mafic rocks, where they're porous, have been proven to be effective CO2 reservoirs. The calcium that exists in the plagioclases can turn supercritical CO2 into mineralized calcite. This has been demonstrated in Iceland. And so on the right here is a model of how supercritical CO2 might flow in a columnar basalt flow, where the porosity during the cooling that's formed, sort of a fracture and jointing porosity that can form. And so if we look at a map of where these igneous provinces, mafic igneous provinces exist in America and North America, the largest and most obvious one is in the Pacific Northwest, where you have the flood basalts. But the second largest deposit of subsurface mafic rocks actually exists in southwestern Oklahoma. And so we think that there's a lot of opportunities to explore this as a possible CO2 sequestration target. And there's a lot more that we can understand, both from a critical minerals source, but also from a CO2 sequestration point of view. I think you're up now.
Right, so kind of getting back to the economic model then, as we saw, carbon capture and storage is in play as a major topic that we're going to have to confront. The other thing we have to confront is this need that if we're going to offset those wedges of hydrocarbon use, the EV fleet is going to have to grow. And I think many people in this room have probably scratched their heads about this and had some concern. I think your everyday citizen probably has not truly reckoned with the implications of this. In the American Association of State Geologists for entirely no report, this gives you a kind of sense of what you're looking at. More than 400% increase in lithium, cobalt, graphite, 200% increase in vanadium, nickel. This is not even considering the rare earth elements. The entire supply chain of the metals and elements needed to generate the modern technologies that we use already, much less the ramp up in the battery powered fleet that we're expecting to have over the next decade. The raw materials are simply not quite there yet. And so this was a picture I took driving by my old hometown, Austin, Texas. On the, on your left, you see the flaring just down the road from Tesla Road, where the new plant is. So I think I love that picture. So this is basically, Carl found some great kind of large headline press releases of the kinds of things we're seeing. EV production facility in Oklahoma City, Woodside Energy. These are coming out more and more. Every day we're hearing more and more regional, mid-continent ramp-ups in domestic production of things that are part of this energy transition. So it's here. For example, the rare earth metals manufacturing facility building out in Stillwater is a good example. So if we step back and look at the geography of this, the USGS compiles something called Earth MRI. It's a catalog of all of the critical minerals, and we participate in that. Lindsay Hunt here is our lead person on our connection with USGS's Earth MRI program. And what they do is catalog where these opportunities are. And here you see all of these mineral deposits going from things as familiar as nickel to things that I've never heard of, damas, DTM. So if you're a metals or a chemist person, you have a great opportunity to understand the distribution of these elements. And what you see is the area Carl was just talking about, that Wichita uplift region, where the edge of that rift is exposed, is obviously a hotbed and a historic mineral belt in this space. But we also see things like, as we go to the east, a number of other elemental opportunities. So we are actually, many people in the room, David Hull and Andrew Cullen will talk later. They led a wonderful field trip through the phosphate belt to the Woodford. And we can see there, these phosphate nodules are enriched in rare earth elements. We're looking at them in the region in partnership with the DOE, Kansas Geologic Survey, the Osage Mineral Council. Basically looking at the old coal belts and the underclays around the coal belts that are enriched in rare earth elements as well. So this organic shale and hydrocarbon facies. Similarly, as Carl was just saying, as we go down to the southwest part of the state, we're starting to look in the region around the Wichitas and how those minerals might be present out in the sediments of the flat, away from the wilderness areas, which obviously are paramount to preserve. Many people here know, but some may not, that Oklahoma is the only domestic producer of iodine. This is the product of the kind of work we're talking about in this presentation and throughout the day, largely looking at really the brines and the waters and the subsurface, eventually creating this brine mining situation here where iodine is produced. And I'm going to turn it back to Carl, because Carl just completed a study that was begun by Kyle Murray, a hydrogeologist who worked with the survey and is now an independent consultant, and looking through produced water records, because it bears exactly on this topic of how do we look at the subsurface fluids as a resource.
Thank you. So if you take the USGS produced water database and you plot all the samples from Oklahoma where there's been any kind of produced water chemistry done in the state of Oklahoma, this is the map that you get. The Oklahoma Corporation Commission 10 years ago said that if for all new saltwater disposal wells, some amount of elemental chemistry needs to be done on the water as part of the permitting process. And so Kyle Murray started a project in coordination with the Oklahoma Water Resource Board to begin to compile and aggregate that data to supplement the USGS's database of produced water quality, hopefully to build out brine as a resource play model to find recoverable either critical minerals or other useful metals. And so these are the additional data points. 500 data points we could actually spot on the map with another 1,000 data points of additional water chemistry data that we could not put on the map, but maybe could put in counties. A lot of these were in response to the Miss Frank and the stack and scoop play. The downside is that if you look at what elements are available in those analyses, most of them are understandably leaning towards the salinity and the weight and the risk of scale. And so this is a pivot plot based on different geologic zones that these are being produced from, largely disposed in the Arbuckle or other Pennsylvania sands. And you can say that we get pH and TDS and barium and calcium and chlorides and iron, magnesium, sodium, and these dissolved gases. The only point I want to make on this slide is that from a regulatory stance or from an exploration stance, we're going to need to expand on some of these analyses. For example, lithium and brines. We're going to have a talk from Galvanic Energy later today about their lithium brine in the Smackover Formation. And if we want to recreate some of those successes or have a better understanding of a lithium systems model that could be exploited, we need to collect these kinds of data more frequently. So speaking on lithium specifically, though, I had the opportunity to go to Brent Wilson's TGS talk earlier this year. And I asked him if finding lithium was really just a function of finding the saltiest water you can. And it's really not. There's a subsurface system that hasn't really been played out yet. For example, if I took seawater and I'd begun to evaporate it and evaporate it and evaporate it until various salts were precipitating. You get aragonite, then gypsum, then halite, and at 99.99% evaporated out, you have potash, potassium salts falling out of solution, and you still have uneconomic quantities of lithium in that water. You get 15.3 parts per million at that. In most cases, the economic plays in Canada, they say they need 50 parts per million, but in America, we kind of need closer to 100 parts per million in a lot of cases minimum. So it's not just a matter of concentrating seawater. There's geologic systems in place and opportunities to understand these. And so while we're getting a lot better at understanding lithium, perhaps from a surface exploration in the Clayton Valley or pegmatite belts or the salar systems in Chile and Argentina, or in Salton Sea out in California, we haven't found a way to translate these surface exploration systems into subsurface models that we can then exploit as we begin exploring for other resources in the subsurface and deep brines. So I think that concludes our talk. I'll let Nick wrap it up here.
Yeah, so I hope this gave you a picture of some of the parts of the survey's research and service that maybe aren't always seen, and show you how these are on the ramp up, and hope we can find ways to work with all of you on making this a reality of really understanding our resource potential, both in terms of the hydrocarbon production, which, as Carl was showing earlier, continues to and will continue, and that we do have an understanding of how it couples with produced water production and other implications that the survey is an integral part of monitoring and mitigating, but then also enhancing production and supporting the hydrocarbon economy, but then seeing that there's these inevitabilities of other kinds of geostorage, other kinds of supply chains that we're looking at that are going to be important. So this is today's session. We're coming up to something we didn't talk at all about, which is geothermal energy. And we left that to Saeed Salehi from OU, who is our resident expert, and he'll give our next talk. After that, we'll have a break and some chats, and we can look at the core and look at some posters, and then we'll have Jake talk to us about seismicity, continue that conversation. Owen Mills from the OWRB was really gracious to come and talk with us about produced water and the OWRB's view of water in general. A term that's been around for a long time is the water energy nexus, and how the state has an agency that plays a role in that. Then we're going to have some guests from the Urbana-Champaign. Cheryl Stroud is going to show how using earthquakes are really important for understanding carbon capture sites where it's going to scale. And one of our national type of examples in Illinois. Lorena was gracious enough to join us to talk from the VEG about how they're approaching the hydrogen economy in an organization that's larger than the OGS, but comparable to the Bureau of Economic Geology. And then we'll have Mig here. Mig will be here in time. If you don't see him, don't worry. He'll be here in time to give a talk on geologic carbon sequestration. Then we'll hear from Galvanic Energy and Pat McLaughlin, and then Andrew Cullen are all going to tell us about the critical mineral supply chain and these topics. So it should be an exciting day. I hope you have a great time. And I'm gonna
Panel discussion.
oh, and then we'll have a panel discussion at the end. So looking forward to that. So let's